Good morning, everyone. If I just want to confirm you can hear me, so if a couple of you could reflect that in the chat line, that would be nice. Thank you, Conrad. Okay, today we're going to work on chapter 3 material. I'll first begin though with a couple of comments. You have quiz 2 today at 1 o'clock. That quiz will be open for access for 15 minutes. So from 1 to 1:15, you'll have the ability to access the quiz. It will run for 25 minutes once you begin. The runtime for the quiz begins when you log in. So if you log in at 1:05, then you would have 25 minutes from there to complete the quiz. The meeting's being recorded and has been since I started speaking about a minute and a half ago. I will draw your attention to the end of chapter questions, some of which are identified in the asynchronous lectures, and those ones you should do at the absolute very least. And there are many more that can be done and should be done at the end of chapter as well. So please spend a fair amount of time doing those questions. As I've mentioned before, if you're stumped on a question, send me your work and I'll try to look at it quickly and give you some advice on where the stump may be. If necessary, I'll ask that you join me in my personal room, WebEx personal room, to discuss it further if that's necessary. Or you could, in yourself, after you've sent me the question, just ask to meet me there as well. Sometimes the emails back and forth to solve a problem can get rather lengthy, and I don't want to mislead you due to sort of off-the-cuff speaking in email or text typing in email. So sometimes face-to-face works a little faster for all parties. But in any event, I do urge you to do as many end of chapter questions as possible, especially those that are noted in the asynchronous lectures that have been provided. I don't believe we've reviewed quiz 1. I thought I was going to do that last week, and I may have lost track of it. So what I will do today is maybe you can confirm that. From Matt. So I assume, Matt, you're referring to my comment, and that's good. In that I will post access to that quiz, quiz number 1, at 2 o'clock today. I'll leave it open for about half an hour, plus minus, and you can take a look at it. It'll show you all of your questions, those you got right, which presumably don't need any further attention. And it'll show you those that you did not get right. It'll show the correct answer to give you guidance on how you perhaps should have responded. So I'll do my best to set that up here on conclusion of this lecture for your review of quiz 1. Okay, those are my comments, I think, that I want to start with. And I'll now share with you my, since I located here, I will share with you my document camera. So you should now see that document camera, and if I'll assume you can see it unless you tell me in the chat line that you cannot see it. So let me get my my chat information up here.
Hey, Wayne.
Yeah?
Do you know anything about the midterm yet?
It'll be a little, not a lot. It'll be on chapters 1, 2, and 3. Primarily chapters 2 and 3. I normally stick to mathematical questions on both my midterm and final. On occasion, I do put a question in there that's more theory oriented, which would then open up the possibility of a question coming from chapter 1 as well. Chapter 1 is all about talk, if you will, as opposed to mathematics. So that I can share with you. I'll give you at least a 1 week's notice of it coming up. But I want to see, at least for today, how well we progress with chapter 3. And then I can maybe project as to when we will finish chapter 3 and then set a date for it. So that's about all I know about it right now. Hopefully that gives you the some information. I can't tell you at this time. I can't tell you at this time. I just want to open this up. Sorry here. I can't tell you at this time the details about it. It'll have 8 or 9, possibly 10 questions. Lately, I've been going with 9, but I've been thinking about reducing that. So you'll get 8 or 9 questions. They are mathematically based. It'll generally run, the questions will be presented to you in the quiz tool, but that's just for viewing it. And determining what it is you must do in the midterm as well as for the final. I'll then have you work all of those questions. You don't have to write the question out, but you do have to clearly label the questions on your paper. I prefer you use lined paper, makes it easier for me to mark it. And you should be able to then scan it and send it to me by putting it back into a Dropbox, which will be dedicated for that purpose. So that's sort of the mechanics of it, if you will. And hopefully that's doable by all, if you will.
So do you know the date?
No, I don't at this time. As I say, I will probably have a better feeling for it after we finish today, because I need to get through whether we're going to need 2 weeks or 3 weeks to do chapter 3. I don't know that right now. It depends on how we progress. So you're looking at probably at least 2 weeks away, probably 3. I'm just guessing here for us to do that. But I can't give you a date right now, and I'm a little uneasy to give even a best estimate, if you will, simply because someone may not tune in later and be geared towards a wrong date if I make a change in it. So I'd like to just keep, apart from generalities, not tie it down to a specific date. It will be sent out to everybody by email, which is my pattern for quizzes and for exams, is to send the whole class through Learn emailing. Which gives me a complete list of everybody in the class, and I just email everybody the same message. But those are the times I'm sort of looking at, if you will, 2 to 3 weeks away from now. But again, I will confirm that with an email, perhaps later this week, possibly, but I do need to get my head around just how well this chapter is progressing. Some of the stuff in this chapter, you'll be exposed to it for the first time, and there's a lot of information in there to digest in chapter 3, and more importantly, to utilize in chapter 3. So what I want to do today then is work our problems either end of chapter or supplementary. And as I've indicated, I'm not seeing anything in the chat line to the otherwise. Let me just back up here a little bit. Yeah, so I'm assuming you all can see my graph paper that I tend to use for working problems, and we're going to work with supplementary problem 3A to begin with. So if you'd like to take a look at that problem, it basically is a pretty straightforward problem in that it talks about how much will be in the bank account at the end of 15 years if $100 is invested today, and the nominal interest rate is 8% compounded annually. So if you were to do a cash flow diagram for that, let me just see this, and you should now start using the concept of a cash flow diagram. It will run for, we'll say 15 years. That's what it says in the question. So 15 years. And what else do you have to begin with? It's a $100 investment. Now, as I've mentioned before, when you're dealing with an investment of money as opposed to investing in equipment, it is still an outlay of cash. What you're doing is giving the money, so it is a disbursement. You are giving the money to the bank, although you might presume it's your money, but in reality, you've given it to the bank, and in return, they're going to give you back that money with some interest on it. But what the question is asking for is how much will be there after the 15 years. So this is essentially what you have. Now, depending upon whether the question says, and it does not in this case, you take the money out immediately or you leave it in your account, it's kind of indifferent to me. I generally only show, for the most part, if you will, what you're given in the question. So what else we're given in here is the interest rate. So the interest rate is going to be, and it is a nominal interest rate at that. So I'm just going to white that out here and put it in as an R. So or maybe I'll put it this way, the interest equals 8% compounded semi-annually. So the question itself tells you it's nominal, but you would know it's nominal because it's compounded semi-annual. That means the compounding period is twice a year. That's what it translates into. So after 6 months, whatever interest you earn will be added to the initial amount, and you'll now have that to work and earn you more interest, if you will. But now it's earning interest on interest as we continue on through the compounding periods. So we can't work with nominal interest, but we need to resolve it by either solving it with either a sub-period interest rate or a effective interest rate. It's the term I was looking for there in my head. So what we have here is, let's solve it with the IS, if you will. What I should have put on here before I go any further is how much this is. It's $100. Now, of course, that could be any amount. It could be $1,000, could be $10,000. The process is exactly the same as to what we're going to do, but the return would be greater if you invest more to begin with. And what we're after is what is the return. So let's assume, and it can go either way here if it's not specified in the question. It could be assumed that you're not going to take it out. You're going to leave the money in the bank, and it's going to come down to here. And if you want to show this on the cash flow diagram, you can. You don't have to, because it's not a given in the question. What you have here, though, is, I'll just put it in here as a question mark. We don't know what it is. That's what we're trying to solve for. So we're looking for a future value given a present value. So to go about this, and knowing that we cannot work with a nominal interest rate, we must work with either a sub-period or an effective interest rate, and we'll do both in this question. But it says for problem A, solve by using part A, 3A, part A, solve by using the sub-period interest rate and appendix A. So let's take a look at that. And this is the first time you've used this appendix, which is basically factors that you're going to extract, if you will, from that table. So we'll do that one here. And so part A will be right here. And it will be, we need to solve for IS, the sub-period interest rate, I subscript S. Sometimes I say that without mentioning subscript. So if you hear the word IS, what I mean by that is I subscript S, or I subscript E if it's I say IE. So those are terms, but they're kind of general speaking, if you will. Theoretically, it's a subscript, and I should probably say that in the word, and I certainly would if I was speaking to a client or something to that effect. So what we need here is 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 going to be equal to R, the nominal interest rate, over the number of compounding periods, which in turn is equal to, and because we're only dividing, we can leave this as a percentage if you like. You could put it in as a decimal. It's not a big deal. And there's 2 compounding periods. So our sub-period interest rate every 6 months, every semi-annual, it will be 4%. So that's the number we have. Now we're also, for continuing on with this, and I will caution you here in that, although this was a pretty straightforward divide, if you will, 2 into 8 gives you 4, and there's no need to worry about decimal places. If this did end up with decimal places, carry at least 4 or 5 decimal places in the percentage, because this number is going to be used later, as you'll see. And when you start truncating early here, then you're introducing an error throughout the balance of your question. So you do not want to truncate or round off, if you prefer that term, prematurely. So we're looking for this. The formula we would use here, if we're using the tables, would be we're looking for F, we know P, and we're going to multiply it by a factor, and that reads, what is F? If we know P, we know I, and we know N. So I will work it this way. The present value is 100 right here. And the notation for this is what is F? If we know P, I is 4% because we're using the sub-period rate. So we're going to put in 4% here. And N are the number of compounding periods. So I'll just pause for a minute. How many compounding periods are there? Someone give me a couple of answers, or hopefully just in the book. So I've got a couple of 30s coming up, and that would be correct. 30. It's 30 because it's every 6 months, twice a year. 15 years, 2 times 15 gives you the 30. Now it's not unthinkable. It's not. It might even be valuable if you even wrote that in here. N would be equal to 2 times 15 equal to 30. The more information you give me on the exam of this nature, it gives me more insight as to how you're proceeding through the question and able to salvage some values if you messed up later in the question. Normally, we would then turn this to the next level of calculations. So we have 100 here, and now we're going to turn our attention to the factor in the book. So I'm going to do this right here. And what we have is, I'm going to go to Appendix A, which is somewhere here. And as we talked about at the close of last lecture, we're looking for the 4%. Well, I'm going to kind of show it here. And what do we have here? On the left, we have 0.5%, 1%, 1.5, 2%, 3%, 4%. That's what we want. The sub-period interest rate is 4%. So we're on the right table now. N is 30, number of compounding periods. So we're going to come all the way down to here. That's not quite showing, so I'll see if I can fix it just enough here. And we are using, to solve this, the compound amount factor. The compound amount factor is a factor that takes a present value and is utilized to get a future value. Now you can learn the names of these different factors, and as you can see here, there's 1, 2, and these apply to single payments, and that's what we have, one payment. These will apply here to annuities, 4 of them, and 1 over here for the arithmetic gradient, which we will also get to in this chapter. So we want to use, and what I tend to do, just not to lose track of my getting some of these terms mixed up, I look at the next column here. And the column I want to use from the question, and let me flip back to that because we've already done that, I want to use the FPIN column. And the FPIN column is here, which is the compound amount factor. So these terms, one over top of the other here, are saying the same thing. One is expressed as a term, the other is expressed as a factor statement. And you can go either way on that. So that's the column I want. So the multiple here is 3.2434. So 3.2434. And if I multiply that out here, I would have obviously then $324.34. So that would take care of all of that. Now, you could work it with the prime formulas in place of this if you were so inclined. There'd be nothing wrong with that. But as we get further into some of this work, some of these problems, the prime formulas become a little more complex. So you should try to focus on using the factors from the tables in Appendix A wherever that opportunity comes about. That will save you notable time on an exam for a question. So I would urge you to become familiar with the ability. Now, there will be times you cannot use it. Simply either I or N are not in the tables that you work with. Now, we can use a process referred to as linear interpolation, which in itself, though, is somewhat time consuming as well. So let's just take a look at this and see what we have. That's part A, and that's the answer to part A. Now, though, it says, let's look at it here. I want to look at my questions here. It says, by using the subperiod rate and the formula 2.1. So that would mean for part B here, if we'd done it that way, and we're using in this question, as I mentioned, we're using the subperiod interest rate, so that's not going to change. So again, keep in mind when you're doing these, do not rely on a different segment of the question as having been already done. Each segment should in itself provide a full solution. So we need to calculate what will IS be for B. It's not going to be any different than above. So it's a quick copy, providing you did it correctly. It's going to be 8% over 2. 4%. That's what we have here. Now, here we would place, and we're going to use the formula. It tells you outright. The future value will be equal to the present value, and formula 2.1 in the textbook, also at the back of the, also at the back of the book on the formula pages, which are also in Learn, where I've copied them over to a and placed them into a PDF folder, a file, if you will, in Learn, so that that's readily available to you. So we have here the formula of 2.1 would be 1 plus I to the power of n. And if we did that, we would have here 100 onto 1 plus I. I is 4%. But now we have to work in decimals because we're starting to add these together. It's not a simple multiplication here. So it's 0.04 to the power of n. And n, again, has not changed. It's still semi-annual. So it's going to be 30. And if you do that arithmetic, 1.04 to the power of 30 multiplied by 100 will give you an answer of 324.34. Now, I suspect a couple of you will do that as we're talking, and if you come up with anything different, please indicate so. I'll give you a second just to run that quick arithmetic drill, because you should be familiar with your calculator and know it well enough to do these things rather quickly. Not always can we use the factor, so sometimes we have to revert back to the prime formula. And again, in a case like this, the arithmetic is pretty straightforward, not too challenging at all. However, as we get into using annuities and as we get into using gradients, these formulas are not quite as simple as this one right here. They are a little more complex, and especially if you in turn, maybe I'll word that differently, these formulas become a little more complex, but if the factors can be used, it's going to save you a notable amount of time on your exams. So again, use factors from Appendix A whenever the data allows you to do so. Okay. So part C here, let's do it. And part C of this question says solve by using the effective interest rate and formula 2.1. So let's take a look at that. So we want to calculate what is IE now, and it's going to be equal to 1 plus R over M to the power of M minus 1, which means it's going to be equal to 1 plus R. The nominal interest rate is 8%, so 0.08 over M. M are the number of compounding intervals or periods within the year in this case. So it's 2.
Can you raise
To the
your voice
power-
a little bit?
Yes, and thank you for pointing that out. We'll try it here. What's not quite working right here? Maybe if I angle it this way. Bear with me, and I'll just refocus that, just make sure it's sharp. So we have that, and then M is the same M here. These are both the same values. So M is 2 minus 1. And if you do that arithmetic, excuse me, yeah, that's what we want here. So if we do that, we're going to end up here with IE equal to 8.16%. Okay, so you see we have no table for 8.16. So that tells us now, because of the IE, we went that route as opposed to IS, we won't be able to use the tables. We're going to have to use the prime formulas, or the parent formulas, I sometimes call them. So we'll go back to that basic. So right here we have F will be equal to the present value multiplied by 1 plus I to the power of N. And by doing that, we end up with the present value is still 100. Nothing has changed there. 1 plus, now we're using the effective interest rate here. That will be I want to get this correct here. Will be, this will have to be 0.81. Whoops, I screwed that up there. It's got to be, don't have enough zeros in here. Just bear with me. It's going to be 0.0816 to the power of N. Now, the effective interest rate is annual. So what would be N in this case? And N from a couple of you says 15, and that's correct. So with that in mind, and if you do that arithmetic, and I urge you to do it because I'm copying this down from work I've done previously myself, you should get 324.34 cents. So with that in mind, and as you can see here, solution A, solution B, solution C, solution A being a sub-period interest rate, solution C being an effective interest rate, you end up with the same result. So as I mentioned earlier, whether you can do these problems that we're going to be encountering with either I subscript S or I subscript E, but one will be a little more efficient than the other by allowing us to use the tables. We don't have a table for 8.16, but we do have a table here for 4. So IS would be the best route. as you have these problems along the way, you will conclude that IS is more often than not the best way to go, but not always. So keep that in mind. And you'll see as we do more and more problems, as you do even more problems on your own, as to the favorability of leaning towards IS when you have that as an option. What else do I want to say here? Now, the next part is D, part D, and I'm just going to speak to this more than probably write it out, but solve using what would it try that again. Why would it be more challenging to solve this problem by using the effective interest rate and Appendix A? And the problem would be is that, I'll just write this out here, tables, do not support IE at 8.16%. Therefore, we'd have to use linear interpolation which we have yet to talk about, we will in this chapter, or prime formula. So that's why D would be a little more challenging, because you're going to have to introduce additional process through linear interpolation, or perhaps through the prime formula, to end up with the same answer. So as you can see from what we're talking about here, is that there is usually a most efficient way, a most effective way of doing it, as opposed to one that will still give you the same answer, but it'll be somewhat, the calculations will be stretched out, will be greater, will be more involved. And why do that if we don't have to? Okay, so that takes care of problem 3A. The next one on our list is 3.3 that I'd like to do. I will note that I have yet to receive any request to do certain problems. I'll assume that's because you're doing the problems at the end of chapter and that you're solving them and are running into no difficulty. If you are, and you can request that I do that in the classroom or in the lecture room here that we have, and in doing that, you can, I'll set it up as one of the ones that we will work on to solve it for you, but also for your cohorts as well. So I suspect as we get deeper into chapter 3, I will see some more specific requests or requests to do specific problems during the class. Or alternatively, if you're anxious to learn how to do it, you can ask me to look at your work and review it and give you some comments back, either by an email or by a face-to-face over the computer, if you will. So that takes care of 3A. Now I'm going to turn my attention here to EOC 3.3. So I'll just write that here and then I'll fix the camera. Okay, so now we take and turn our attention to 3.3. And if you'll have to look that up in your textbook there. to get the gist of the question. Okay, this one's very similar to the one we actually just did, but that's not a problem to us. Has a slightly different twist, so we can now draw a cash flow diagram from that problem, but let me locate the problem to begin with. In my book, chapter 3 here, end of chapter, and we said it was 3.3. Well, by the way, and this is noted in the asymmetric asynchronous lectures, there's a table in the book noted as table 3.2. Do not use the formulas in that table. The reason being is there's at least 3 different formulas that have errors in them that the author, well, I guess they screwed up is what they did. They didn't check it well enough. But there's formulas in there, at least 3 of them, that I have found that contain errors in the work. So I encourage you to don't use that as a quick reference in solving problems in chapter 3. Table 3.2 is flawed. So with a light pencil, or if it's your book you're going to keep, draw a line through it. Don't use that table, please. Okay, 3.3, I'm still looking for that. Here it is here. How much money will be in an investment at the end of 15 years if $100 is deposited today and the interest rate is 8% compounded annually? That's interesting. So we'll do it. So 3.3, noted up here. Cash flow diagram. It's going to be very, very similar to one we just did. And you don't have to draw this to scale usually. There's a couple where scale would be a little more valuable, I guess. Scale would be a little more valuable to keep track of what's going on in the question. But in most cases, a not to scale diagram is more than adequate. Being neat about it, though, is useful towards you, because of there's going to be times where you have to draw a curved line as opposed to a straight line. And if your curved line starts to look like a straight line, then you won't get the mark for this question, or for that aspect of this question. So have a straight edge handy to you for yourself to use in solving these problems. Kind of considered a part of the package where you need to have a calculator and a ruler at your ready. So in this case, again, 3.3, just looking back at it here, we're dealing with 15 years. So I'll put that on here. And whether that is to here or to here or just to here, you know, the line can be almost of any length. Scale's not that important, but your time line is always the x-axis. The y-axis are the disbursements, which come down, or the receipts that go up. In this case, again, we are looking at it where we are, it's an investment, you're investing money, so it's going to a credit union, to a bank, to some sort of financial institution. It doesn't matter what it is unless it's specifically named, and even then it doesn't matter. I often in my questions use the Bank of Winnipeg, which does not exist when I use it in my questions, to give you an idea when it's a kind of a cash investment into some sort of interest-bearing account. So in this case, we'll keep it pretty simple here. Come down here. The investment from the question, looking back at it, is $100. It's 15 years. And you're looking at what will be there after 15 years. So we'll leave the money in the bank in this case, and I'll just draw this down here. But it's an unknown. We don't know. That's what we're seeking. So excuse me, please. The interest itself So I'll just say I is equal to 8%, just like the earlier question, but it's compounded annually. So again, they're essentially saying 8 is a nominal interest rate because it's compounded, but it's a bit of a it doesn't matter answer or reflection on it, because what we're going to do here is let's calculate what we have here. We're going to do this. We can do it with IS or IE. I'm going to do this one with IE, meaning the effective interest rate. And it's going to be equal to 1 plus R over M to the power of M minus 1. On occasion, and I've done it too, I won't pretend otherwise, I sometimes lose track of this minus 1 and forget to factor that into my work. So be aware, don't drop this minus 1. That's pretty important. So again, the nominal interest rate is 8%. So we're going to have 1 plus 8, 0.08 over M. M is how much? Anybody tell me in the chat line? How much is M? Okay, Dayton says it's 1. Oh, I have it mixed up there. It's 15. N is 15. M for M is in the number of compounding periods in the year. So we want to go with 1 for those of you who are following the chat line. Okay, we forgive you. It happens. M will be 1 to the power of M minus 1. And if you do that arithmetic here, you should end up with 0.08 equal to 8%. So the effective interest rate turns out to be the same in this case as the nominal interest rate. And that's because your compounding period is a year, 1 year, and the effective interest rate is per year. Usually, there will be a few occasions where we deal with it slightly different as a maneuver, but right now, just think of it that way. So if you see it's compounded annually, although that suggests it's nominal, it's also the effective interest rate. So if we're using that, we now jump into our actual formulas. And the formula here says the future value, and that's what we're looking for, a future value. You look at your timeline. This is 0. This is today. This is now. So if you see terms like that, someone invests money today, invests money or purchases something now, they're referring to the fact that this is at time 0. And in this case, we want to know how much will that $100 be at 8% compounded annual in 15 years from now. The diagrams are also useful to get rid of what I call the fluff in the question, because it doesn't matter the name of the company. It doesn't matter what piece of equipment you're buying or what tools you're buying as we get into those sorts of problems. What we want to do is extract out of the problem the basic cash flow information, if you will. That's why it's called a cash flow diagram. And that's what counts. That's where the arithmetic comes from. That's where the algebra, the mathematics, the arithmetic comes from. So the cash flow diagram turns a word problem into helps you turn a word problem into a math problem. Many people in this course will suggest along the way that they have trouble with word problems. They don't get it. Well, what we're doing here is taking the word problem and turning it into a math problem by getting rid of all of that fluff that I talk about. Over here, we're looking for the future value here in 15 years down the road. It's going to be equal to P, the present value. And we're going to see here, I'm taking a quick look. As you learn the tables, you'll be able to answer this quickly, because what you want to know is, do I have a table at 8%? The answer is yes. And do I have an end value in that table at 15 years? The answer is yes. So I can use the factors to solve this one. So that would be what is, and using the terminology and the reference that's in the book, I think it is on page, I'm just going to backtrack to that page, but it is on page, where am I here? It is on the top of page 56, where it says a handy way of thinking of the notation is reading from left to right. What is F given P, I, and N? And that, with the exception, the letters will change. It might be what is A for annuity, if I know P, I, N, or F, I, N, something like that. Okay, so again, that's the phraseology I will use. What is F? That's what I'm looking for. If I know P, I, and N. Now, if I can use the tables, that's what I need to go with. So the table here says P is 100, the cash flow diagram tells us P is 100. This remains here, that's just notation. What is F if I know P? I is 8%. And N in this case, this is effective, this is per year. The number of compounding periods are yearly, 15. So I'll leave it to you right now for a couple of you to look that up, hopefully all of you to look that up in Appendix A and give me the value that I will use as a factor representing what's inside these brackets. And in doing that, you're going to tell me it is how much. If someone could look it up and maybe just put it into the line there. I have one already up already, and that's from Clive. So he's nailed it. 3.1722. You do the multiplication and you have $317.22. So that's what it would be worth if you put $100 in and you don't use it. You just let it save and save and save until for 15 years, and that's what you'd have. That doesn't seem like a lot of money, of course, but if you were today to invest, say $5,000, then you could calculate what you would have in 15 years, or when you turn, I'll say 65, when you want to retire from work and spend your life, I don't know, on the golf course or playing games, becoming a full-time gamer, maybe. So that'll give you some idea of what you would have into the future, be it 2 years, 20 years, or 45 years. The power of compounding interest. The idea that the more frequent the compounding is, the more you will earn, because your interest is earning you more interest as the time goes by. So that would be the answer to that. Now, if I were marking this question, and don't be lulled to sleep on this, because some of the answers are, some of the questions will be a little more challenging than what we're doing now. This is just to get you exposed to it. And right now, I'm frantically looking for my pen. There it is, a different color pen. So if I were doing this, you would get 1 mark here for a correct and cash flow diagram. That would get you 1 mark. For calculating the effective or sub-period interest rate, if needed, sometimes you don't need it, you're given it, you get a mark for that. For setting up the factor formula, 2. For identifying the correct values for the factors in there, 1 for correctly looking that up, and you'd get another 1 for your correct arithmetic, whether you take 1 step or 25 steps to get to here. You'd get 1 mark for that. So a question like this would be worth 1, 2, 3, 4, 5, 6 is what I would identify that at. Now, I do use some discretion, and we will go through that, the cash flow diagram. Sorry, my mistake, bad phrase there. The marking rubric that I use I'm going to go through that with you at the next lecture. If I forget to do that, please someone bring it to my attention, because that is what I'd like to do. Okay, so there's 3.3 done. So the next one that I would like to do is 3.4. 3.4, it's also an EOC. End of chapter 3.4. What we have here. So I need to jump back into here. Okay, this one says, how much should you invest today at 12% interest to accumulate $1 million in 30 years from now? So that might be an interesting scenario for your own personal investment. But it also would apply for maybe not, let's just say you wanted to purchase a piece of equipment. And we'll get into this type of question as we go through this. And the piece of equipment is going to cost you $1 million, and you want to buy it in 5 years. So the question would be, how much should you set aside each year in order to accumulate in 5 years the $1 million that you need? Now, it's not as simple as simply saying, well, all I have to do here is take $1 million and divide it by 5. Because if you do that, you are ignoring interest. Your money is making you money. So you need to factor that in. And therefore, it's not a matter of simple division here. 5 years, I need $1 million. Therefore, I need 200,000 each year to put aside, and I'll be there. But you've left out the interest component if you look at the question in that regard. So let's just see where this one takes us. Cash flow diagram. Okay, why not? Again, I'll go to this. And you
Hey,
want to
Wayne.
have a, yeah?
Sorry, just quick question. Are we having to do this for the quiz today? Like write it out and do the cash flow and all that?
No, and the quiz will all be theory.
Oh, okay.
Yeah, I've lately gone to theory for quizzes and then leave the arithmetical questions to the exams. But if there was one, and I can't say there wouldn't be, but generally I'm going to focus on theory. But if there was one, no. All I want to know is the bottom line, and it would be multiple choice. So one of the answers shown is the correct answer if I were doing that type of thing. So don't sweat that stuff.
Yeah, I was just wondering if we had to post any work or anything like that.
No, not for the quizzes. Sorry, my chocolate lab just came running in here. It's been out for a walk, and yeah, no problem at all. So I'm going to draw a timeline here again, just like before. And they always start out with the time. And the first point here is always 0, today, now. And we're looking at, in this question here, 30 years. But in this case, we want to know, we're going to say it stays in the bank. And I try to qualify that just so you get this arrow correctly, whether it's up or down. I might say you take it out of the bank immediately and start using it. Probably not. If it's for your retirement, you're going to leave it in the bank and draw down on it as time goes on. You'll probably transfer it into some sort of retirement income fund, a RIF, or you might turn it into, leave it in the bank or wherever you made your investment and turn it into an annuity, and therefore receive so much per year or per month as time goes on in retirement as part of your income as you continue into your senior years. None of you are probably worried about that too much today. However, your instructor has to worry about that, given the fact that I am 73 years old. So we know here on the cash flow diagram, we want to have $1 million. That's what we're after in this case. What we want to know, though, is how much do I have to start investing in the bank? That's the unknown one. So in this case, it's the reverse pattern to what we've been using. Instead of going forward to determine amount, we're going to come back to determine amount. And again, this type of question could have just as easily be worded differently, as you will see as we continue to do these, where you wanted that $1 million to buy, I don't know, 2 front-end loaders, for example, if you're into construction, or maybe you want to buy a high-end computer network, or maybe you want to invest in a company. You're going to buy out a company, take ownership of it, and run it as your office now, as your company, if you will. Those are all possibilities. I assume most of you, when you start, will probably start out working for someone. But I've certainly encountered students along the way who are actually more interested in eventually, sooner than later sometimes, starting their own company and providing that service to companies under a contractual arrangement. Those are real possibilities. So keep it in mind in that way, that you might want to be saving money to buy out someone in the future when an opportunity arises. But anyway, back to this question here. And what we have here is we need the interest rate, and it's 12%. So, and let me just look at it. When there is no reference, it's not compounded. It doesn't say it's nominal. So we can assume out of that, the default value for this is really per year. Simple as that, annual. So if there's no specific qualifier on the interest rate, the assumption we will make, that they make in the textbook and that industry makes, if it says 12% with no compounding statement, and it does not say it's nominal, then you can easily assume this is annual. So the interest rate here will be will be equal to 12%. I'm just going to leave it that. That's what it is. Now we could go through that arithmetic and calculate an IE if we wanted to, but we're going to end up back at 12%, just like we did in the earlier question. So just for clarification purposes, I will put equals R as well here. Or sorry, not R, IE, my mistake. That's equal to IE. Because again, if you go through the formula for IE, put in your values of 1 plus 12 over 1 to the power, all to the power of 1 minus 1, you'll end up back at 12%. Because the assumption here is that it is an annual amount, an annual compounding period. Okay, so in this case, though, we're looking at this. We're looking for a present value. Before we put an F there. Now we're looking for a present value, knowing the F value that we're seeking, and using these formulas. In this case, what is P if we know F, I, and N? Excuse me. Okay, that's a different factor. The one we looked up before was what is F if we know PIN. Now we're saying what is P if we know FIN. So let's put the amounts in here that we have. So this is saying here, and I'll work across the page, it's visible. We want the future value to be $1 million. That's good news. What is P if we know F? And that's the F we know. I is 12%. N is 30. Now hopefully we have a table that accommodates that factor. So I'm just going to take a quick look at it. I'm going to look in the table A, and I'm looking for 12%. That's on page 487 if you're following along and want to go quickly to it. And is there an N in there of 30? And yes, there is. So I'm going to extract out of that the factor. Anyone want to tell me? Somebody already has. Thanks, Kelly. So it's going to be equal to $1 million. The factor here, I'll use Kelly's numbers, 0.03338. which, if you do the multiplication on that, would be $33,380 flat. So that's saying by utilizing interest at 12%, you would have to set aside each of those years. No, sorry, you'd have to set aside here today that much money, and it will accumulate interest, and then more interest will be earned on that 33,000 plus the interest you've already earned. So it becomes that compounding effect. Eventually, at 30 years, you would have your $1 million. Okay. So that would answer that type of question. Pretty straightforward. Again, if I were looking at this from a marking perspective, I like my cash flow diagram. It's not ambiguous. It's clear. It's obvious. The values, there's nothing I have to kind of guess. So I'd say, okay, the student gets 1 mark for that. There was no need to calculate IE, so there would not be a mark awarded for that because you had that to begin with. And in this case here, you put down the prime formula, you put down the values that you can insert for that prime. I said prime formula. I should have said factor formula. My mistake. You put down that factor formula, put the values into that factor formulas, you look up the factor, and you do the arithmetic. 1, 2, 3, 4, 5. That question would be worth 5. Now again, they may not be quite as straightforward as this on an exam. It may be a little more complex in nature. Word problems tend to be that way. But essentially, that's all you're doing here. That's the reverse. This number here probably came from a present worth factor would be the name of that. Am I right on that? I'm not looking at it, but it's called a present worth factor, I believe. That would be your second column, not your first. So thanks, Kelly. It would be your second column, your present worth column. So we've now used the formula regarding a compound amount factor, which takes you forward, which is what is F if I know PIN, or in this case, we're using a present worth factor, which is really the reverse. It's the inverse approach. We're taking a future value and bringing it back to the day 0, time 0. And that's what we've done here. So 3.4 is now done. The next one I had on my list is 3.6. Now that one's going to be a little more challenging, it would appear. So let's do it. Get rid of the, we won't worry about these straightforward ones. We'll start looking at some of these. I need a drink of coffee. You mentioned that the difficulty. Questions at the end of chapter is what I would recommend you focus on. End of chapter from Conrad to everyone. So I should always check to see if it's a private before I use your name, but you've opened it to everybody, Conrad. So you would use end of chapter problems and reviewing the worked out examples. When I say reviewing, I don't mean speed reading. I mean working your way through them, examining them very closely, both the examples, worked out examples, I think they're called. And in addition to that, there are review problems also that have been worked out. So worked out review problems at the end of chapter as well. So those would be your primary sources. And if you can handle those, you should do quite well on the exam. The reason we're doing some, and I won't say the easy ones won't show up on the exam, but clearly if you can do the more difficult ones, you should be able to do the easier ones. So you could get either type in that regard. What I consider to be an easier question as opposed to one that's more challenging. But if you do EOC problems that are relevant, when you look at that, and I don't know if there's any in this book, remember it's only, and I'm reflecting what we talked about the first time around, we're only doing part A and Part B questions. So Part A in the back of the book are the key concept problems. Part B are applications. And Part C, which we do not have to do, is more challenging problems. So I stay away from them just to keep this as basic as we can. There's no need to do that. So you would look at those types of problems. Now, if you see a squiggly E with the word Excel on it, for example, if you have your book open, question 3.48, although it's a more challenging problem, that means it needs a spreadsheet. So you will not get on the exam questions that would require a spreadsheet to conclude. So as you go on in the later chapters that we're going to deal with here, you'll see that on a few of the questions. And if you see that these problems to solve, then they're really beyond the scope of our study. So you can park them or put them in the parking lot. Don't need to deal with them at all that way. Just wanted to mention that. The only time you'll have to be exposed or have to be familiar with spreadsheet activities, and you will use Excel when you do it, your two assignments will focus around Excel because again, time's not an issue, and you'll set up your spreadsheet to solve the problem and submit that for grading. Each one is worth 2.5 marks of your final, if you will, 5 in total for the two assignments that I will give you. That won't take place until after the midterm, or I'll say when you get into chapter 4 and 5, and that's probably where they'll come from in that time frame when we're doing chapters 4 and 5. So they're not going to come up immediately. Back to this question here, which one did I say? We're going to do 3.6. Okay, so EOC. £3.6 says here Morris paid £500 a month for 20 years to pay off the mortgage on his Glasgow house. If his down payment was £5,000 and the interest rate was 6% compounded monthly, what was the purchase price of the house? Now, this could be, in our case, it could be you're purchasing a building as an office for you to offer contractual services in your field of studies to clients, if you will. So if I were writing this question and giving it to you, I would probably indicate it's pounds. So I might say in London, buying a home, an office, buying an office in London, something like that. I might change it around that way because I just think it's more applicable. I try to keep the questions worded in the field that you people are studying. So using things like an office as opposed to a house, or you might purchase a house to use as an office. Many professionals do that. Certainly lawyers, consulting companies, land surveyors, they often purchase a building, call it a house, but use it as an office. They convert it over. Again, just giving you some reflection on that. Okay, where am I here? So in this case, we need to come up with, once again, with a cash flow diagram. So again, we're going to use this one a little differently here. Here's our timeline here. It's going to run this way. And because it's pretty straightforward, I don't believe I need to put any tick marks in here for each year. Sometimes it's valuable, but right now it isn't. So 20 years is what the mortgage ran for, and he's going to have to pay money. Now, when you look at this, I'll ask the question for the chat line here. What kind of cash flow is that $500 per month? That's a little different than the cash flows we've been using so far, which were single values, lump sum amounts. Any thoughts? An annuity. Sounds good to me. Sounds good. Because it fits the definition of an annuity. It's the same amount, 500 pounds, over equal intervals or periods, monthly. That fits the definition of an annuity. You can look up the more formal definition in your studies when you probably already come across it already if you've done some pre-work on this chapter, which is what you should have done, and listen to the synchronous lectures. But that fits the definition of an annuity. So you got to be able to extract that out of the problem when it occurs. So we show an annuity slightly different. We're going to show it here. And it starts out at an angled line. I usually use 45 degrees, but it should be from 0 to the end of your first year. These are not numbered here. I guess I could have put a 1, 2, 3, 4, 5, all the way up to 20, but not needed. And then you parallel the balance of that to the timeline to there. And that is, it's an annuity, and it is my symbol for pound is wanting. 500 per month. Okay, so recognize that. Now, some people, and I don't know why they do it, and I won't mark you wrong if you do it, but I've seen some people take the time and they will express this as 20 downlines here. One here, one here, one here, one here, one here, and put 500 at the end of each of those arrows. This is much more direct, laying it out as an annuity. The other is not incorrect, but you're breaking the annuity down to its monthly payments. And drawing this diagram will probably add another minute or so to your time. And again, on an exam, you can go ahead and if you do that, it's costing you time. So express your annuities as I've just shown you here. In addition to that, not yet exposed to it, but in addition to that, we're going to have a different layout, graphical layout for an arithmetic gradient series and for a geometric gradient series. We'll deal with that shortly, probably not today, but that's something to keep in mind. Okay, let me just think for a minute here what I want to do next on this. We've got the 500, it's 20 years, that's all good. What do you think? This cash flow diagram, is it complete or is something missing? What do you think? Incomplete, that's a good answer. Why is it incomplete? The 5,000 down, exactly it. That's a part of your payment right here. And it's down, you paid that a part of the transactions before you went out and probably got a mortgage to conclude it. Probably a $5,000 down payment. And again, I use relative scale. If this is 500, I want it to be a little longer. So I'm going to come here and it's going to be 5,000 pounds. You'll learn, or you probably are picking this up already. First of all, I cannot draw a pound symbol very well. That's one thing you're probably learning. The other thing is that the same formulas work for whatever currency you're dealing with. There's no change. Could be dollars, Canadian dollars, American dollars, could be pounds, it could be the euros. I think there's one in here for one question actually presents itself as the currency for South Africa, I believe, if I remember correctly. So the currency does not matter. The denomination of the currency is irrelevant. It's the numbers we're working with. Just that when you draw up a concluding remark, make sure if you started out with pounds, your answer is going to be in pounds, not dollars. I've actually made that mistake myself occasionally. Okay, so we have that. So again, we've extracted out of this question 3.6 all of the necessary information with the exception I now have to show the interest. So I'll put it up here to save space. I is going to be equal to 6%. And where am I here? It's compounded monthly. Compounded monthly, 6%. Now, when we're looking at this, we see here we have an I as compounded monthly. Now, if we went and calculated the IE, I subscript E, we would have the interest rate in yearly and your payments monthly. That's like adding meters and feet. Just can't do that. You've got to convert one or the other. So because your payments here are monthly and the interest is 6% compounded monthly, we would be smarter to calculate the IS. And the IS will be equal to R over M. R is 6%. And because this is going to be a straightforward division, I'll just put it in here as 6%. And it's compounded monthly. That will be 12 compounding periods per year. That means our interest is going to be 0.5%. So I am asking myself now, do we have a table at, if you will, 0.5 of 1%? And the answer to that is yes, we do in table A. So that's good news. But if we're doing this in our payments are monthly, our interest is monthly, but our timeline is yearly. So we now have to convert that to months. So N, big N, will be equal to 20 by 12, equal to 240 months. So now I'm thinking, okay, if I turn and open up that book in Appendix A, I'm going to find a table that says 0.5%. And then I'm going to go down the left-hand column and find out I have no N for 240. It goes, N is beyond the extent of the table. So I cannot use the tables. If I can't use the tables, I've got to go back to prime formulas. Sometimes I call them parent formulas. So if we have to use the parent formula here, it's unfortunate, and there'll be times we don't have to. We can use the factor statements. But the parent formula is we want to convert this annuity into a present value. We want to bring that back to here because we want to know how much did the house cost at the beginning. What wording did they use? What was the purchase price of the house? So if this is our payment of annuities, this is our annuity payment, we want to bring it back, convert it into a single amount at time 0. So the formula we'd have to use, and we can't use the factor formula in this case, although I typically set them up that way, and I encourage you to do it too. I'll start out this way and say, well, the present value, which is what I'm looking for here, is going to be equal to what is P. P is equal to A, the annuity, onto what is P, if I know the annuity, I and N. And if I put values into this, the annuity is 500 pounds, so we're good there. P, what is P if I know A? We know that annuity, 500. I is 0.5%, and N is 240. So now that I have that there, I realize I cannot use the factor here. I can do this, but I can't do that. So I've got to go back and put in the parent formula here. The parent formula would be P is equal to A onto, and it is 1 plus I to the power of N minus 1 over I onto 1 plus I to the power of N. That will be the formula that will convert an annuity into a present value. Unfortunately, and I know I'm repeating myself, but I want to make sure we are understanding this as we go along the way for everyone. We cannot use the factor tables because the table that shows us factors for 1/2 of 1% interest, 0.5 of 1%, does not have an N value for 240. So we've got to revert back to the principal, the prime, the parent formula. So we're going to put these values in here. And these values here will be the annuity, and I'm just going to use numbers here, but it's 500 pounds onto 1 plus the interest. The interest rate is 0.05. We need decimals here in order to add these together. We can't do it as a percentage. To the power of N, which is 240, minus 1 over I, which is 0.05, onto 1 plus 0.05 to the power of 240.
Sorry, is it a 0.5%? So wouldn't that be 0.005?
And you're quite correct. Yep. Yep. Thank you for pointing that out. I'll try to make that. Don't be sorry, by the way, for those types of statements. They're more than fair. Try to squeeze that in here. Good pickup on that, by the way. .005. Probably if I'd done this up here, I wouldn't make that mistake. Excuse me. Okay. So we're going to do the arithmetic on that. Anybody have an answer for me? When you use a table, you can use the tables for I subscript S or I subscript E. But of course, you have to have a table for that interest value and an N value within that table for that for the problem we're solving. So we have here as an answer, and I have one. Do I have a concurrence? 69,790.39. So we're telling us here it is 69,000. I want to take it out of the book here. Just give me the minute here, out of the chat line. 790.39 pounds. So the question would be now to pick up on one that was asked of me, and the answer to your question about later is yes. That's how I've set this up to keep it as straightforward as possible. What we've done is converted this annuity here to a single amount at time 0. Now, we got to forget, though, when we don't want to forget that when we bought the house, in this case, we had a down payment of $5,000. So therefore, the actual purchase price, we'll call it that, P is going to be equal to 69,790.39 plus 5,000 equal to 74,790 and 39. I don't know if they say pence or whatever. And not really that much better. I'll keep working on my symbols for pounds. But that's what it would be. The cost of the house would have been 74,790.39 pounds is what it would have been. It's how you set it up. Sometimes I'm just want to respond to Fabian on that. It's how you set it up. I would not mark you wrong this way. It's fine. But you could simply say this could be P1 here if you want. P1, P1. And this could be then P0. One not meaning, just a notation to keep it separate. That's all it would be. So I would see easily what you're doing there. And you would not be penalized for that at all. And then you have to add it. Now, another way to do that is to factor that in up here. In other words, I could have said down payment plus A onto this. And I would have carried the 5,000 through the calculations. So the P value at the end would be what we now have at 74,790.39. Again, I wanted to keep the two components of the answer separate so you understand what we're doing. But you, by all means, and I would encourage it now that you've seen what we're doing here in this type of question, when you have a down payment, is that this could have read, and I would read it now, it would say P, no subscript, P equal to down payment plus A onto PAIN. Go through this process here, 5,000 plus 500, Realize I cannot use my tables. So I then go here, down payment plus A onto fill in the values. It would have 5,000 ahead of here. And then when you calculate this out, you would actually have this value here. So there's nothing wrong with that. I actually encourage it. That's how I have done it, straightforward. But again, I tend to, in the first go around on these types of questions, kind of break it into a little component parts so that you appreciate what we're doing there and not lose focus on working towards the solution. You will find that as we go on, you'll be using time. There'll be times when we have more than one factor that comes into play for solving a question. And again, we can break it down into component parts and do each one separately and then sum them all up at the end. Or we can build them all into your first line equation, if you will, and solve it that way. I'm indifferent as to marking it, as long as you go through it. And again, the importance of, I don't want to insult anybody, but I sometimes struggle with people who are scribblers rather than decent printers. And if I can't follow it, I don't spend a lot of time trying to decipher it. So again, a nice clean, a nice clean presentation of your values is pretty important so that if you do go astray, for example, here, if we're doing this, and you worked it down this far but didn't get 74, you stopped here because you forgot about the 5,000 pounds, you would probably get full value minus 1. So you would still get that. So I don't just, everything does not pivot on your last value, providing I can see what you did. Another occasion might be is you did what I did. You put in your interest at 0.05 and worked it through. Well, you're showing me you know the process. So you might get 3 out of 5 or 2.5 out of 5 if that sort of mistake was made and not get a 0 on it. So again, with my own sort of latitude when I mark a question, I tend to try to find marks, but if I have to be able to read what you're giving me, on the paper. I have to be able to follow through. It's not ambiguous. It's clear. It's straightforward. There's a pattern to how you lay it out. So a question like this, again, you'd get one for here, and you would get one for here because you had to compute that. You'd get one for here, this formula here, and then one for here, one for here, and that's what you'd have. The answer, maybe I would say one for here. I might rub that out here. I might say one for there. You normally won't get a mark because you add two numbers together. So you get one for here. So 1, 2, 3, 4, 5. A question like that would be worth 5 marks. And I use some discretion when I put a value on a question. A question like this, just to give people who did it right, I would ask for a concluding, or what's another term I sometimes use, a concluding or decision statement. So if you have a concluding statement, and that will be asked for. If I ask for a concluding statement and you give me one that contains the correct value and makes the correct statement, that would also be worth 1 mark, is how I tend to mark it. Okay. Now, I tend to lay out my questions so you'll know what I'm looking for. That's only fair. So if you got that question 3.6, in addition to what's been printed there, I would say your work must include a cash flow diagram and a concluding statement. That's, if I do not ask for them, there'd be no marks awarded for it. You may still do it, but there would be nothing in it. So again, pay attention to the question. What am I asking you to give me? So something like that, almost without any doubt in my mind, I would say your work must include a cash flow diagram and a concluding statement. That sets up the check mark here and the check mark here. Sorry, I'm off the map here a little bit. I'm not sure how much you saw. So the concluding statement would be extracting it from the question. It could read something like nothing more than maybe saying Morris paid 74,790.39 pounds to purchase the Glasgow house. There's your concluding statement. That tends to come into more play as we get into chapter 4, where we start doing comparisons. Because in chapter 4, you'll get 2 scenarios, 3 scenarios, probably not more than 3, although you could in the real world. And you work them through separately, and you have to make a choice as to which of the options you would choose and why. That usually, and normally I call that a decision statement. Just again, to prep you, to prime you for thinking a little bit as we get into more and more material. So for example here, and I'll just talk off the top of my house here, off the top of my head here, if you were looking at perhaps 3 different models of a front-end loader, they cost a different amount. The financial arrangements may be different for each one, and you would go through it and you would solve what each one in turn is going to cost you today if you buy it, because it's an if. Which one will you go with? What option will you choose? And I would then ask for a decision statement and why. Now, in that case, it would be because you are getting a viable piece of equipment that does the job. It's not deficient in any way. You've looked at 3 options. They all fit the need. So you're going to tell me, in that case, you would choose option B because it is the lowest cost to you. In other cases, as our questions get a little more involved, there may be other factors that come into that concluding or that decision statement that we'll deal with as we get into it. So let's take a look at one more before we wrap it up for today, I hope. And let's look at what's my next one here? 3.7 is my next one. EOC. 3.7. These are the questions that I've asked you to do in the asynchronous lectures that I gave you. I said you should now pause this video and solve problem whatever. These ones I'm doing are the ones that have been listed in those slide decks and in that voiceover to the slides. So let's do our cash flow diagram. It says here it is 3.7. It's an industrial juicer. I think this is probably at a cost of $45,000. So it's probably not something you buy at Walmart and put on your countertop at home to crush some oranges with. It's probably something that's, well, as it says there, it's industrial. So this is a high-end industrial standard type of juicer. In the classroom, I tend to have pictures with my questions if they're on the board, for example, when I'm showing the question on the board. But anyway, that's for another time. I don't do that here because it just doesn't lend itself very well to that sort of presentation of information. So it costs $45,000. It will be used for 5 years and then sold to a remarketer for $25,000. So you're getting money back. Good news. If interest is 15%, what net yearly savings are needed to justify its purchase? Okay, so here's a question where we're trying to find out, given our projection of using a piece of equipment earning us money, will it earn us enough money to go forward with the purchase? That's what we're after here. So therefore, we're going to set this up here as a timeline, and it is for 5 years. I believe that's in the question. I just want to make sure. Yeah, it will be used for 5 years. And the initial cost is $45,000. So we'll put that here. Excuse me. And what we want to know is, I want to go back to the question here. What net yearly savings are needed to justify the purchase? So we want to know, we want to convert that into an annuity. So I'm going to put in this question here 2 more things. One is our unknown. So I'm going to just draw that first and then ask you a question here. So the annuity here is, if we convert that into an annuity, that's our unknown. A is equal to the unknown. That's what we're trying to solve for. What is the, how they worded in the question here? What net yearly savings? So we want to convert our expenses into an annual amount. That would be an annuity, times 0 here. Now, what am I missing off of this diagram? Anybody? I can tell you we are. Say again, I think you had it.
25,000.
That's right, that's a salvage value. So after 5 years, you're going to sell it, and in your estimation, it's going to be 25,000 here. So if you buy it, then sell it, what will be your annual, what will be that annual amount, combining all of that together? And that's telling you how much money this piece of equipment has to make you every year. If not, it's a bad purchase. It's normally not customary to buy a piece of equipment that won't make you money. So if it makes you money, that's a good deal. And that's what this question is leading into. Now, to solve this type of question, we're going to use the capital recovery formula. And the capital recovery formula looks like it gives you an annuity to begin with. Excuse me. And it will be equal to the purchase price minus the salvage value. They're in brackets onto the capital recovery formula, the capital recovery factor statement, which will be what is A if we know the purchase price, we know I, and we know N, plus S, the salvage value multiplied by I, the interest rate. So that's your capital recovery formula. That is on page 59, close up 3.1. Now you can work this as two separate entities here. Treat this and convert that into the annuity. Treat this and convert that into an annuity and add them together. But the capital recovery formula allows you to work them together. So that would be the smart way. Okay, so let's put this to here. Purchase price is $45,000 minus the salvage value of $25,000, and that will be the net present value, if you will. And it's onto what is A. If we know P, that'll be the effect of these two numbers. I, which we haven't worked yet, but it's said in the question, I is equal to 15%. I should put that up here with this. So it's on the page. I need to see it on anything you do for me. And I just want to go back to the question. It says if the interest is 15%, it's not compounded. So we can treat that as an effective interest rate. It's annual. And I want to go calling it an effective interest rate because I want to stay with the 5 years here. I don't want to have to convert that into months by doing converting that interest rate to an I, assuming it to be an IS. That would mean then we have 60 years, and I don't know if the tables will support that or not. So anyway, what we have here, I is 15%, and N, this is years, and N is in years, so they are compatible. Plus the salvage value of $25,000 multiplied by the interest rate, 15%. I'll put it in that way. I could have put it in as 0.15. No different, whatever you want to do. Okay, so the next step is I can clean this up a little bit. And we would do that by saying this would be 20,000 onto this factor. Can anyone give me that factor out of the book? Now this is an annuity, and the column you're looking for is the APIN column. And the APIN formula column would be your capital recovery factor. Anybody have it? So I have it on the chat line there, 0.29832. And that agrees with my number as well. Plus 25,000 onto 0.15. So we can add those together. I should have said more than add them together. We should do the arithmetic, I'll put it that way. And if you do, you should get a value of minus 9716.40 per year. So the capital recovery formula normally gives you a negative number because it is the sum effect of the purchase less the salvage value down the road in 5 years in this case. So that's what you would have. So that's telling us now that in order to make money from this piece of equipment would have to earn us $9,716.40 per year to offset this expense, because that's the total expense, everything summed up. So you'd need the opposite amount. You need to make $9,716.40 for each of the 5 years to justify this purchase. Otherwise, if you can only generate from this $7,000, but the net effect of the cost is $9,700, just for round figures, you're losing money. Why would you do that? You would want to look for a better deal somewhere, or you may have to increase the amount of return you would get by broadening your market to other people, doing some marketing of your product, which might be nothing more than squeezing some oranges or some tomatoes or some, I don't know, making smoothies or something like that, whatever. So that's what it's telling you. Now, common mistakes before we close off here. I have seen students not recognizing the order of arithmetical operations. And as we get into slightly more challenging questions, the order of operation is significant. So I would say I have seen people determine this factor here, multiply it by 25,000, and then subtract that from 45,000. That is not the correct order of operations. These are in brackets. So you've got to do these first, then multiply by the factor. Do not take the S value and multiply it by the factor and then subtract it from 45,000. And that occurs from students. So again, I'm just giving you some heads up on it. The other type of mistake I've seen on this from time to time is that they write this out, the actual, call it the factor formula, but when they move to this line, they forget this part. They forget to carry it in the arithmetic. Maybe I could even do it here. So therefore, the recovery component, the salvage component of this is just dropped. Those are the two most common errors I see in this type of question when you're dealing with the capital recovery formula. The capital recovery formula is built around the capital recovery factor. So we are combining that. Now, an alternate approach to this, if you were inclined that way, would be to say, let's convert that to an annuity. Let's convert this to an annuity. This would be negative. This would be positive. And if you did that, you'd end up with the same amount of money. You'd have a plus here as the annuity. I should have worded it differently. This would be a negative as an annuity. This would be a positive as an annuity. And then you'd sum them together, which would give you the net effect of buying and then salvaging later, and tells you how much money you would need to make in order to pay for this piece of equipment. So if this piece of equipment generates for you $15,000 every year, that's a good deal. The other thing to keep in mind, and I noted it in the synchronous lectures, the asynchronous lectures, I noted it in there, but the solution for this in Appendix B is incorrect. They indicate that it should be $18,400 per year. That is a wrong answer. I have triple checked it, and I'm very confident in telling you this is the correct answer. That answer is in the answers I've provided in Learn. It's the correct one. But if you open up the back of the book, you're going to spend a lot of time trying to come up with $18,400. Just isn't going to happen. It's a wrong answer. So I wanted you to be aware of that as I look at it. Should A be negative? It is negative here. But because what they're saying here, it's on the top part here because they're saying how much do you have to make in savings from this piece of equipment. So that value will be the opposite to this. This will be negative as it is. This, though, to offset it, it has to be positive for your break-even point. So that's why I've shown it up here on the top part of the line. That is what you have to do. And the question reads, where is it there? What net yearly savings are needed to justify it? So these was how much you have to make. That's a receipt. Your savings are a receipt. But to determine that value, you have to find out what is the net effect of this cost offset by this return through salvage. So that's why it shows up that way as in the calculations is negative, but you need to have that to break even. You need that same amount as a positive in this question, the way it's worded. So hopefully that explains it for you there, Fabian.
Well, but like if you follow through, it doesn't give you the negative. So do you just put it in?
Yeah, you put it in. When you look at the material in the book, you will see, with a few exceptions, you will see that, and you're correct with your observation, by the way, you will see that when you look at it in the book, that the capital recovery formula will give you a negative value. So the negative is not expressed in the formula. And there are times, say for example, here it was a house you bought for $45,000 and you sold it later for $88,000. Then it would be positive in that case. So you kind of have to look at the content of the situation you're dealing with to determine whether it's negative or positive. Ordinarily, equipment does not appreciate, it depreciates. So it's going to be negative, the combined effect of buying offset by a salvage. But in the case of a house, which appreciates in value, usually, not always, of course, but if you buy a house today for $250,000, hopefully in 5 years you'd sell it for $315,000. That effect, although you wouldn't call it a salvage value, it is a resale of the house, but you would still use the same formula. So you have to look at context from the question as to, in the end, this is going to give you a negative. It's only, I mean, think of it in terms of buying a car. If you buy a car today for $35,000 or a truck for $45,000, and 5 years you sell it and you get $15,000 back, the net effect of that cost and resale is going to be a negative. It's cost you money. And that's how you have to look at it that way, because the car depreciates in value. But if it were for something that appreciated in value, and the only thing I can think of right now is a house, a home, an office building, those things tend to appreciate in value, and therefore the value here would be positive that you would get here, and you'd have it directly for here, for that annuity. So hopefully that gives you some insight, but you raise an excellent question on that, because I had to read it a couple of times a few years ago when I first went through this material. To recognize this, just like you were coming up with there, Fabian, this doesn't make sense, you know. But when I looked at it and applied logic to it, then I settled easily in my mind that, yeah, that's what it is. So that's all I have for you today. We only have 2 minutes left. Continue doing end of chapter problems over the next little while. And we'll do more of these next week. And next week, I will announce when the exam will be for the midterm. Okay. It'll probably have 8 or 9 questions in it. As I've mentioned, shouldn't be repeating this, I guess. 8 or 9 questions. It'll be presented to you through the Learn Quiz tool, but you'll have to do your work on paper, scan it, and put it into a Dropbox, which will be dedicated for that purpose. And I will articulate that in the instructions to undertake it ahead of time. When I announce the date for the midterm, I will stipulate those sorts of instructions so that you know how to do it. Now, I'm hoping all of you have scanning capacity. If you don't, because your scanner's broken, or maybe you don't even have one, you could take pictures of it with your smartphone. And then some smartphones today, you can create your own PDF in there in your smartphone, or send it each picture to your computer and bring them all together as a PDF, and then put that into your Dropbox. I prefer that. It just saves me a lot of time. Try not to send me individual pictures, because for me to mark them, I generally will print them out, and I'd much sooner just use one print command to print out a full PDF than to have to do it 8 times, because there's 8 questions in there, and have it go through the printing sequence 8 times as opposed to 1. Just makes it quite a bit quicker for me. Also, I noticed last time a lot of people are using a light leaded pencil. Pencil's no problem, but try to use something, because once it's scanned and put into a PDF, sometimes what I'm seeing is very faint, and it's hard for me to determine what you're telling me. And in a couple occasions last time, I couldn't read it. It was just too faint from taking usually a picture of it and then converting that to a PDF. But try to use a heavier pen or a heavy leaded pencil, if you will. That would be really good to do. Any questions? As typical, I'm going to close down right here the sharing of this, and I will stay online here. And if anyone, until everyone or almost everyone is gone, I usually don't wait for the last couple to leave, partly because sometimes people have fallen asleep and they don't know the lecture's over and they're still showing up as being at the meeting. The quiz, I'll have to finish the quiz, chapter 3, before I can designate a time for it. It will not be next week, and I'll give you at least 1 week notice on it. Di, I see, oh, did you just log off? Yeah, you went there, yeah.
And Wayne, you said you'll specify on the midterm if it's required for a cash flow diagram and
Yep, each on a per question basis. So
Okay.
it won't be like a blanket statement on the first page. Each question will stand alone as to what I want.
Okay,
Yeah, absolutely.
thank you.
You're very welcome.
Hey, you said it was going to be all theory today on today's quiz. Just wanted to confirm that.
Yes, and I've put the quiz together. It's probably not showing up on your Learn yet. I hide them until the 11th hour. But no, I believe there's no math requirements. You don't need a calculator, to my knowledge, or if it is, it's pretty Mickey Mouse stuff. But it's basically pivoting around theory. Nothing like we've been doing
Okay,
here.
thanks a lot.
You're very welcome.
Okay, thanks. Bye.
Bye. Yep. Yeah, we'll probably have the quiz ahead of the midterm for B. Hope I'm pronouncing that correctly for you. Oh, I shouldn't have said that. I'm sorry. You sent it privately. I apologize.
Wayne, I've got a question.
Sure.
If I have a significantly more comprehensive list of like the different like interest factors, like it's not the list in the textbook, like it's a separate list I have, would I be able to use, like, I'm just wondering in questions, would I be able to use that rather than, like, if it's not in the textbook list, would I be able to use that list, or do you want me to calculate it out using the formulas given?
No, you shouldn't use your own list of formulas. Like, in other words, if the textbook ones don't give it to you, then you should use the formulas to calculate it.
All right.
If I understand your question correctly, because again, I want to examine you on, you know, do you know how to use the tables and do you know how to do it longhand if necessary? Because sometimes that's the way it is. You will find though that you'll be able to generate your own factors as we go further into this course for all of the situations in Appendix A. That'll be pivoting off of one of the assignments that we have. But for now, I would want to see either the extraction of a factor from the tables that you have from this course, being Appendix A, and if you can do that, use them. If not, you have to revert back to the prime formula.
All right.